Hello, I'm Richard Patterson. Welcome to another episode from IPC Irwin. And in these demonstrations, we're going to look at how we can use the IPC Irwin Westminster power supply for studying all aspects of electromagnetism. Now, the unit is a specialised power supply which provides a very high current at either AC, that's the yellow terminals, or DC, the red and black, which is needed for experiments with electromagnetism. The unit is basically a transformer with just a few secondary turns, so it can withstand a short circuit. There's no trip or anything in there, which would be the case if we connected just a single strip of wire across the terminals there. Students would have to be careful. It can warm up the wires, so switch it off when you're not actually doing the experiment and let it cool down. Now, it works with the Westminster Electromagnetics Kit, which has got lots of components in it. It's got magnetic compasses, wires, iron filings, and lots of components to build some of the applications of electromagnetism, such as the electric motor, a buzzer, a doorbell, a transformer, and a dynamo. The first experiment with the Westminster pack is to recreate the Danish physicist Hans Christian Ørsted's 1820 discovery that an electric current passing through this orange wire will deflect a magnetic compass. So at the moment we've got the current is zero, it's the power supply switched off, and the compass is pointing in our studio here to magnetic north. So what I'm going to do is switch on the power supply, and there'll be about 5 amps going through the orange wire, and watch what happens to the compass. First thing is to bring the wire and put it parallel over the compass needle, so you can now see that the compass is deflected and it's pointing right angles to the wire. So what we're going to do now is switch off the power supply and reverse the current. The wire is getting quite warm now, so as I said before, switch off the power supply whenever you can, otherwise the wires and parts of the circuit can get a little warm. The second experiment is to move on and get the wire mounted vertically using a retort stand and a couple of clamps. And I've put a bit of wood packing underneath the bottom here to support a white piece of paper. You can use card. And the compass is there, it's pointing to magnetic north again, and it's in front of the wire. So if we switch on now, there's our deflection. It's pointing towards me. And what I'm going to do now to investigate the shape of the magnetic field around the wire is I'm just going to gently pull the compass around the wire and note which direction the needle is pointing. So to do that, we just slide it round. And your students, if they do this, should observe that if we think about the point of the compass, it's called a plotting compass, it's tracing out a circle. So if you've done basic magnetism using permanent magnets in the school, they'll have met magnetic fields and magnetic field lines. They might have used compasses and iron filings, and they'll know about the shapes around permanent magnets. Well, the shape of the magnetic field around this current carrying conductor is circular, and we can investigate it further in the next little clip when we use iron filings. So what I'm going to do now is very gently sprinkle a small quantity of these iron filings around the wire. They'll settle randomly on the white piece of paper, and then again, very carefully and patiently, I'm going to tap the card lightly with my finger and watch what happens. There we are. So I can't really see any pattern there. That's just a random iron filings on the card. We'll switch on and again just lightly tap the card and wait and see what happens. So after being very patient and just gently tapping the card, you can see that the iron filings have now settled down into what we call concentric circles. If we just look at this area here, the clumps of iron filings are forming circles around the vertical wire, which is the shape of a magnetic field. So I'll get rid of all the iron filings, by using this magnet to scoop them up. Some groups of students, it's inappropriate to use iron filings because they can get all over the place, and worse, they can get into students' eyes, which is not good news. That's a bit of an emergency. It can scratch the cornea. So away with the iron filings, and we're now going to look at one of the memory aids for this. And I'm going to use my right hand. This is called the right hand grip rule, and I'm gripping the wire with my right hand. My thumb is pointing upwards, which is the direction of the current. And my fingers are going to be the direction by which the magnetic field, the circular magnetic field, points to. Because remember, a magnetic field, as well as having shape, has got direction. So I'm going to make sure the students know that the current is coming up. So just check that this wire here is connected to the red. So the current is coming below the card, it's going up there. So when I put my hand in there, the thumb is pointing in the direction of the current. And if we now switch on, there's the compass pointing around the wire, and it is pointing in the direction that my fingers are gripping the wire with. So that's the first. It's called the right hand grip rule, and it's one of the memory aids we've got for this topic. So thank you for watching. That's a brief introduction to some of the experiments you can do in electromagnetism using the Westminster power supply. As ever, here's our QR code, which will link you to the IOP Spark practical site. There's lots of experiments there. There's easily about 15 of them. For health and safety, we've included the CLEAPS link on low voltage power supplies. And you can also look at the Irwin website itself for setup instructions using this unit, and you can download our teaching notes.